So excellent. As you can see on the board, this is the question. 2 raised the power 2x plus 2 is equals to 9 multiplying 2 raised the power x minus 2. Peter and Michael, if you are watching, this is the question. Okay, now we're going to break it down for everybody to understand. And some of you are hiding your faces, pretending you have solved the question. But here we are together. Let's set the ball rolling. Now, we remember that if we have an indices A, for instance, A exponent x times A exponent y is always given as ax plus y. I'm very sure you remember this. So, this is what we are going to apply to where we see 2 raised to the power x plus 2. If we employ this property, then this will be 2 raised to the power 2x multiplying 2 raised to the power 2. Agreed? Fantastic. But, you know, this can also be broken down as 2 raised to the power 2 into bracket x multiplying 2 raised to the power 2. Remember, recap, that if we have a raised to the power x multiplying y, is always given as axy. That is what we have applied over here. Okay? Now, by so doing, let's move a little bit up and see. Then we can say 2 raised to the power 2 into bracket x multiplying 2 is given as 4 multiplying 2 raised to the power x into bracket 2. Okay? Now, let's substitute back to the original equation A. Then we can say that 4 times 2 raised to the power x to 2 is equals to 9 times 2 raised to the power x minus 2. Isn't it? Okay. Now, there is a commonality. Now, we have this and that, which are the same. So, let's solve the equation so easily by doing a bit of substitution. So, let's say y equals to 2 raised to the power x. Okay, so that we can say the 4 into bracket y2 is equals to 9 times y minus 2. Okay, and that will be 4y squared. Okay, is equals to 9y minus 2. Let's rearrange this equation. Pull everything on the left. So then this implies that 4y squared minus 9y plus 2 is just equals to 0. Then this is very familiar. This very equation that we have derived is very familiar to our general quadratic equation. So we say as quadratic in y. Okay, if we use the general quadratic equation, then we can say that our a is equals to 4, b is equals to negative 9, c is equals to 2. Then we can say that y is equals to negative b plus or minus square roots of b squared minus 4ac all over 2a. So substituting the respective value into the equation, we'll be able to compute it. But yes, though, we know that if we take the coefficient of s of y squared multiplying by 2, we get 8. And the real factors of 8 will be negative 1 times negative 8. Okay? So when we substitute back to the equation, then we're going to get 4y squared minus y and minus 8y plus 2 is equal to 0. Okay? Let's simply solve this quadratic equation by pulling y out of this. Okay? So now we have 4y squared minus y minus 8y. Okay? So if I bring y out of this, I'm going to get 4y minus 1. In the same way, here, if I bring 2 out, I'm going to get 4y minus 1. This goes to 0. So y minus 2 into bracket. Finally, 4y minus 1 equals to 0. Okay? Then it implies that our y is equal to 2 and y is equal to 1 over 4. Well, this is beautiful. But that is not the final answer, because we employed a substitution earlier. So let's go up and see. Our substitution, let's call this one the substituent. Let's see. Okay, let us mark it like that. It's y raised to the power 2 to x. So y raised to the power 2 to x is the substitution. Okay, so then we putting back the respective values into the equation. We have 2 equals to 2 raised to the power x and 4 negative 1, which is 1, 4 is equals to what? 2 raised to the power x. Okay, so x is equals to what? 1. And here, for this, we can say that 2 raised to the power negative 2 is equals to 2 raised to the power x. Remember, if we have 1 over x is the same as x raised to the power negative x. That's a property of indices. Okay, so therefore x is equals to 1 and x is equals to negative 2 is the solution. Awesome. So let's do a quick recap